Hey guys, today we're going to be doing the LeetCode question search suggestion systems. So given an array of strings products and a string search word, we want to design a system that suggests at most 3 product names from products after each character of search word is typed. Suggested products should have common prefix with the search word, and if there are more than 3 products with a common prefix, return the 3 lexicographically minimum products. Return a list of lists of the suggested products after each character of search word is typed. So you can basically think of this as like an autocomplete system where a user enters one character and gets a list of outputs corresponding to the character. And if you type another character corresponding to that, and so on and so forth. So let's look at the first example where we have an array of products and a search word over here, which is mouse. So our output, as mentioned, is going to be a list of lists, and each list is going to correspond to each character of the search word. So if we look at the first character of the search word, which is M, we're going to have the outputs as mobile, moneypot, and monitor. And if we look at the next character, which is going to be MO, we're going to have the same outputs, mobile, moneypot, and monitor, as each word starts with MO, MO, and MO. And as we go to the next list, which is going to be for the characters MOU, we're going to have our output as mouse and mousepad, as these are the only 2 words which have the substring of characters MOU. And as we go on, we're going to have the next set of characters as MOUS, and our output is going to be the same, mouse and mousepad. And finally, we're going to go through the entire string MOUSE, and our output is going to be mouse and mousepad. So I hope this example made sense. You can go through the other examples as well just to get an idea of the problem statement. We have another example over here where the product is Havana and the search word is Tatiana. And in this case, since none of the characters of the search word match the product, our output is just going to be a list of empty lists. So thinking of our solution, the first thing that we can do is sort our product list, since we need to get the products lexicographically. It makes more sense to sort it. So let's go ahead and do that. Arrays dot sort of products. And now let's go ahead and create our result. And now we're basically going to go through each one of our characters of our search word, and we're going to create lists for each character, and then we're going to compare the products which are now sorted lexicographically and check if they have that starting character. So I'm going to create a for loop and iterate through each character. So I is going to be less than search word dot length and I plus plus. And now we're going to create our we're going to create a new string which is basically going to consist of each character every time we iterate through the loop. So new word is equal to search word dot substring 0, I plus 1. So this basically means since we're iterating through search word, we're going to iterate to the position 0, I, as in the substring function I plus 1 is not included. It's just going to include the characters from 0 and I. So that's first going to have M, and then MO, and then MOU, and so on and so forth in our example for mouse. And next we're going to create, so for each character we need to create a new list in our list of lists. So result.add new array list. And now we want to iterate through our products list, which should now be sorted. So for string product in products, now we want to do a check and check if the product that we are currently at starts with our new word that we have gotten at line number 8. So if product that starts with new word, and if that's the case, that means we have found the minimum lexicographical word which matches with the customer typed search word, and so we want to add that to our suggestion system. So result.get of I, and this is basically going to get this new list that we've added for this particular character at line number 9 dot add product. And that's pretty much it. The final case that we have to take care of is that once we have 3 products for each list, we want to break out of that list and go to the next one. So we can do that with a simple if case over here. If result dot get of I dot size is equal to 3, we can just break. So just to quickly run through the steps that we did prior to this, we first sorted our array lexicographically, and we're then iterating through our search word, and this new word string is going to hold each character as we iterate through the word, and we're then going to create a list for each character. And then once we iterate through each product, we're going to check if the product starts with the new word, which is the substring that we created, and if it does, we're going to add that to the list. And once we have 3 products to the list, we're just going to break out. So finally, we just return our result, and that should be our entire code. So let's just see if this works. Awesome, it does. So that's it for the entire code. We're finally just going to discuss the time complexity and space complexity. So the time complexity for this, if we first see, we are sorting the list of products. So that is going to be O of n log n, where n is the total number of products in the product list. And also we have a double for loop where we're basically iterating through the total length of a search word over here, and also iterating through each product. So that is going to be m into n, where m is the length of a search word and n is the total number of products. Keep in mind that since we are coding in Java, we are also performing the substring function and the starts with function, and strings are immutable in Java, so any operation that is done with strings is quite expensive, and so that is also going to cost an extra O of m squared time complexity. So that is something that you can discuss with your interviewer based on what function or what language you are using. But overall, using this method, the time complexity should be O of n log n plus m of n. And similarly, the space complexity should just be O of m. And the reason is we are iterating through m characters in m total number of characters in our search word, so we will have m number of lists in our list of lists, and the maximum number of products we can have in each list is going to be 3. So our space complexity is going to be 3 into m, and since 3 is constant, it's just going to be O of m. So that's pretty much the entire code and the solution for this problem. I hope this was informative. Thank you so much for watching, and I'll see you in the next one.